Artifact 11, Standard 6.2, ISTE Criterion 20. Manage the use of technology for learning in a non-traditional classroom setting. Scratch.mit.edu is an online tool that students can use to create cartoons with backgrounds and characters that speak and move. They can have mini slides and they can move from one background to the next. They can make it as short or as long as they want. There are limitless opportunities for using this technology for non-traditional ways and in non-traditional settings to use design and to express creativity. So this storyboarding project was completed in 2 small group math resource classes. Students could choose to work with a group or individually. They used scratch coding to create their storyboards with characters who explained triangle theorems while talking together. So I had that connection to the math content. They had complete freedom, however, in the creation of their storyboards and characters. Before we started the project, I went over the following technology guidelines. First, they had to follow the acceptable technology use guidelines for Gwinnett County Public Schools. They've seen them before, but they needed a timely reminder. Also, students should only be on the scratch.mit.edu website and not surfing the web. Storylines, characters, and language should be school appropriate. And they needed to use positive and constructive comments when viewing other student projects. After going over the guidelines, I also monitored technology by walking around the classroom and being involved in the projects and watching what they were doing and answering questions. My own under construction storyboard was projected on the board. We all worked together to solve problems and to share strategies as we managed the technology. Before the project, I had collaborated with the computer science teacher. On one day before the project, when students were making test corrections, upon finishing, they went to the computer science lab. This was a new experience for them. None of the students had yet had the opportunity to take computer science class. I had never before let them leave my class to go somewhere else and do something else. It was like going on a field trip. While there, the computer science teacher gave them a brief introduction, which served as their first taste of scratch coding. Here is a group of students in small group math resource class working together on a project that doesn't feel like math. They are using technology appropriately, they are fully engaged, and they are developing computational thinking skills without realizing it. They think they are just having fun. Artifact 11, Standard 6.3, ISTE Criterion 21. Create opportunities for students to use a design process and/or computational thinking. In the process of creating storyboards, my students used the design thinking process of creative play, which has the 5 steps of inspire, imagine, create, play, and share. In the first step, Inspire, students saw examples of storyboards in the computer science class. They also saw my in-process project projected on the board. For the Imagine step, students imagined who their characters would be and what the background would look like. They sketched ideas on paper first and discussed ideas with their peers. For the Create step, students were given full creative freedom to choose their backgrounds and characters. They had to write down the conversations about triangle theorems, then they had to use computational thinking to make the timing work. For step 4, play, students ran their stories to make sure that they worked. They played them over and over to make sure the timing was correct for both movement and speaking, and they had a good time doing that. The last step is share. Students were eager to share with their peers and parents. Some students worked on the storyboards at home and got help from family members. They were eager to show their work without regard for its level of sophistication. Here is a screenshot of the announcement on my eClass page that I posted to encourage sharing. I told the parents about the project and I gave them the link that they could go to the site I encouraged the parents to ask their child to visit the site with them and share their work. Some of the students did that. They took a few days at home, they worked with family members, and they came back and reported how helpful that was. And they were just so excited to be sharing a project with their parents and their family members. And here is a snapshot from one scene of a student's work with the code showing use of computational thinking. Her story ended up working perfectly, actually better than mine. As a reminder, this child has a learning disability, and yet, through this fun and creative project, she figured out how to place the code blocks to make the timing of the conversations flow smoothly. This was an excellent tool for developing computational thinking skills with my students. Artifact 11, Standard 6.4, ISTE Criterion 22, Model and Nurture Creativity. To start this project, I first showed students a sample from scratch.mit.edu, and that's a picture of me at the board doing that. We watched some tutorials with sample Scratch boards. Students were immediately excited, fully engaged, and eager to get started. Their creative juices started flowing right away. When they saw this example of someone coding a Minecraft game, it blew their minds, and they immediately started clicking away. I could not stop them from getting started. While they were working, I projected my own first effort at Scratch coding on the board. It was simple with lots of room for improvement. I kept it projected on the board so that students could see my creative expression and also see me making improvements. This first image is from my initial effort found at scratch.mit.edu. The second image is the coding for my own storyboard. I also projected this on the board when working on it to model problem solving and computational thinking. Their projects were completely different from mine, but seeing my efforts modeled sparked their own creative efforts. It was wonderful to see students expressing themselves personally and culturally. One Hispanic student's characters were Hispanic. My Japanese students' characters were Godzilla and Mothra. African American students' characters were African American. And they all used computational thinking to create the timing for conversation bubbles and scene transitions. They were excited to have complete choice in the creative process and to learn about coding. Every student was completely engaged during the 75-minute class. Those who did not finish in class completed it at home. Some students needed a few days to complete it, but they all did so without me prompting them to get it finished and turned in. So here we have Lindsay showing off her completed project. She is so proud. This student was usually very shy and hesitant to speak up in class. She never wanted to show her work. But when she finished this project, there was no hesitation. She eagerly volunteered to project her completed storyboard for everyone to see. It was a wonderful product, and I was so proud of her too.